So I'll be presenting our project. So my name is Sai Rathod. I am from Vishwakarma Institute of Technology, and today I'll be presenting our major project, that is patient monitoring and database system. So a brief introduction. Poor healthcare and medical consultation services are still a major issue faced by our country, and this is prevalent in both the areas, that is rural areas as well as the urban areas. This leads to a poor diagnosis and incomplete treatment of patient, which further puts a pressure on the Indian medical healthcare system. Applications such as medicine reminders and online consultation apps, such as I won't take any names, but they have tried to improve the healthcare system and treatments, but they weren't very accurate. So this project that we are talking about today, yes. So this project that we are talking about today is a solution that gets the benefits of both the worlds. That is the online connectivity, which complements the effectiveness of offline diagnosis. Here's some data. According to omcare.com, they conducted a study, and out of 6 lakh patients out there, 44% of patients, it was seen that there was a delay in medication. They didn't take their medicines at time. 39% of the patients completely forgot to take the medicines, and 20% people still had their non-updated expired medicine prescription. So yes, this issue is very real, and it can pose some very harmful and problems in the future. So our project that we are focusing on is developing a public Android application that provides patient monitoring and database management solutions. The app that we are talking about features an efficient medicine reminder system that allows patients to easily keep track of their medication schedules. And this is another extended feature that we provide, that is, when a patient dismisses a medicine reminder, the exact intake time is automatically stored in a database for future reference and monitoring by the doctor. So if I dismiss a reminder right now, that the actual time that I was prescribed by the doctor while feeding the prescription on the app, against my medicine taking time, the actual time and the time that I take the medicine, both can be compared, both can be tallied by the doctor, and see and the doctor can basically see if the patient is taking his medicines on time or not. Then again, the next the application also allows for virtualization of important patient data, which includes the medical records. This provides patients with a centralized location to store their medical information, making it accessible and organized. What I'm talking about is, whenever we go to a new hospital, they provide us with a file, right? So rather than doing that, we'll have all that data in a centralized location, that is our app. This app will have all your medical info, and this will act as your file, your online filing system for all those, for referring in the future and for referring to the doctor. Moving on, by providing patients with these tools, we hope to improve medication adherence and ultimately improve patient outcomes. What we intend to do with the app is that we want to improve the patient's treatment results. The patient should be able to recover quickly, and he should get all those benefits that he's paying all that money for. The objectives that we have in our mind, that we had in our mind when developing this app, there are four major objectives. There is monitoring, there's analysis, there's digitalizing, and there's connectivity. And there are sub objectives. I'll just explain what those mean. So under monitoring, there's medicine reminder, as I already talked about. There's medical intake database, that is the when you dismiss the reminder, that time goes into the database and the doctor can tally the actual time and your intake time, and this can be used for monitoring by the doctor. There's analysis, um, the display of past test results, medical reports, and all that stuff can be displayed right on the app through um, presentations like bar graph, histogram, pie charts, other stuff. It can be visually presented so that the patient has an idea about um, how his reports, what was his situations like 6 months ago, maybe a year ago. And yes, that's all about analysis. Then there's digitalizing, that is the digital filing system that I talked about. There's digital prescription that would be fed by the doctor right on the app. There's we can also provide a medical certificate through the app. And UPI payments, online transactions that the hospital charges the patients, that can be done through the app as well. These, the stuff that I'm talking about right now, has a bigger what can I say, a benefit that I'll be talking about in a few minutes. Then there's the fourth objective, that is connectivity. We provide a doctor patient messaging feature so that even after the diagnosis is over, the offline diagnosis is over, the patient, the doctor can monitor the patient, and he can talk, he can still stay in contact, he can still stay in touch with the patient, and give him valuable inputs. And then there's ambulance calling and tracking. I'll explain this one too in a minute. Yes, off to the demonstration. I'll demonstrate the app, and just give me a minute.
Sir, are you playing the demonstration?
Yes, miss. Just a second. Yeah. So that's our app. The name is Kashyap. I'm audible, right? Hello.
Yes, sir. Go ahead. Go ahead.
Okay. So as I was telling, that's our app, Kashyap. This is the login page that you need to first register, and the basic app stuff. You log in with an email, and okay. So there are two types of login that we provide. As I said, this app is going to be a more general use app, so it can be used by both the patients as well as the doctors of India. So there are two login types. There's patient and there's doctor. I'll just go forward with the patient for now. The first time you log in, they ask for all your basic stuff: your name, mobile number, gender, date of birth, and age. The basic stuff, so that there is the app basically collects some important information, so that they can so that the contact can be established. Okay, so that's the home page. The filing system that I was talking about, that's medical records. So there's all your medical records. You can upload a pic of yourself. There's your personal information, your name, contact number, and basic stuff. We also extended this personal information by adding relatives name and adding relatives contact as well, so that the older populations that are using the app, we are able to contact them too. So there's no loss of contact, loss of any sort of touch in the future. And say if we want to talk, or if we want to talk to someone, some relative, it's emergency situation, so in that case as well, this relative's name and relation type, that stuff comes in handy. Then there's your medical data. There's your height, weight, blood group. There's your more medical data, such as your surgical history, your genetic history, vaccine history. In this, you can basically tell the app your uh, surgeries in the future, past, your genetic history, that is, if you have any sort of genetic disorders, the vaccine histories, vaccines that you have taken in the past, chronic diseases that you are suffering from, like there's asthma, there's AIDS, there's arthritis, there's obesity, stuff like that. There's allergies, medicine allergies, all that stuff. We want to we will further extend on the um, medical records part of the app in the near future. Then there's lifestyle part. So the app also asks you about your smoking habits, your alcohol consumption, there's tobacco consumption, activity, there's your diet, the type of the diet that you follow, whether it is vegetarian or non-vegetarian. You can even edit the data in the future, so that it's never too rigid. The system is never too rigid. It can be flexible and can be modified as per your will. um, then there's the ambulance feature that I'll be showcasing right now. So what the app does is it gathers the
Uh,
data.
sir,
Yes.
sir, kindly, like other participants are on the queue to present their
Okay.
presentation. So kindly adhere the timing, sir.
Okay, sorry, just give me a hot 3 minutes and I'll wrap up.
Sure,
uh,
sir.
all right. So what the app does is, in the ambulance feature, it pings all the nearest hospitals, and you can basically call the hospitals that provide the ambulance service and establish an appointment with them, so that the you can basically contact the hospital for ambulance, and they'll be on their way to your place. They know your location right on the app, and you can track the ambulance on the map. So uh, there's a two-way contact between the ambulance service and your and you, that is the patient in emergency. There's patient profile that the doctor can refer to. Okay, so we are back on the login page. I'll showcase the doctor part of the app now. So there's doctor login. I'll log in. Yeah. So in doctor login, the app asks more stuff in the while logging in. There's medical registration number, education, specialty, to make sure that the person trying to register is a doctor. Yes. That's the home page. The doctor can basically search for a patient through his email address. Yeah, so the account, the profile that I was on previously, that profile is shown here. There's your name, gender, and age, so that the doctor can make sure it's that person. Yes, so I'll just show the prescription part. There's your basic stuff: patient name, weight, date, that's in your medicine prescription. That's your paper prescription. But here's the twist: So there are three modes of adding medicines. There's on schedule, in which you can input the time. The doctor can input the time of the day that you are supposed to take the medicines. You can input multiple times, the start date and end date, so that yeah, you know that when to stop taking medicines. Then yeah, then there's at intervals, so that if the doctor asks you to take medicines after 6 hours of interval, after 4 hours of interval. And then there's the when needed. So if the doctor asks you to take medicines in certain conditions, in that case you are supposed, like for example pain or swelling, in that case you take the when needed medicines. And yeah, so that's basically the app demonstration. You can see that I have successfully prescribed medication to my patient profile. And yeah, that's it for the app demonstration. I'll just wrap up in a minute. um, mm, okay. Yeah. Huh. Okay. So what we are trying to do is, the project aims to help India with the digital revolution. The data that is stored in the app is safe and secure. It's stored on a cloud-based platform, and the data is stored virtually. So there's never the fear of data getting lost. So it can be referred to in the future. The digital storage also allows the app to generate charts and graphs, and there's visual representation collected based on the data collected over a span of time. And since the prescriptions are fed digitally, this reduces the patient's dependency on chemists for interpretation. So most of the times when we go to a doctor, the doctor's handwriting is illegible. So it's never, we never really understand what he is trying to tell. So since the prescriptions are fed virtually, we can always refer to the prescription itself in the future. The messaging feature allows doctors to remain in touch with the patient, as I already told a few minutes ago. And the online payments feature helps the government keep an eye on the money charged by the hospital, so that the hospital so that the government can make sure that the hospital is um, uh, charging money, charging money that is in the limits. The hospital is not overcharging. So the government can ensure that stuff through the online payments on the app, tracking of online payments on the app. The future scope, uh, we plan to make Kashyap a one-stop solution for all the people of India. All the medical services, all your database, all your treatment history, your patient reports, your doctor, uh, your messages, your chats with the doctor, every stuff, we want to make that centralized and right on the app. Partnering with the government of India, we also want to, we would like to partner with the government of India as well, because it would really open new horizons for us and for the app as well. The big data that is generated by the population that will be using the app, data such as information about demographics, the medical history, diagnosis, treatment outcomes of the patient, could be further used for disease analysis, tracking outbreaks, and monitoring effectiveness of a cure by the government. So yes, the app has a lot of future scope, and it could be even used as a government app, a public sector client app as well. So yes, that was all about it. That was all about patient monitoring and database system, and that's all about Kashyap. So I thank you guys for listening. And this was Saish Rathod. And yeah, thanks.
Thank you. That was a wonderful presentation and a good demonstration.
Thank you, ma'am. Thank you.
Good evening, everyone. My name is Ayush Sharma. I'm from Delhi Technological University, and I'll be presenting my presentation will be on university recommendation system. So, university recommendation system helps to provide students with an insight of the universities, which they'll be able to, uh, you know, they'll be able to easily get into with the scores that they have. Like initially, if they have GPA of their college and the TOEFL scores and the SAT scores that they have given for the college admission, they through them they'll be able to apply to some foreign universities, and we help them to be easily able to get into. So that is our motivation to have students for higher studies in other countries. They the university selection process is a challenging task, as a lot of different criteria needs to be considered. This problem can be addressed by modeling a recommended system based on various classification algorithms. So the flow will be the first of all we'll get the data from a credible source, and our source is at academics.com. We scrape the data and then we get the raw data. After that, we clean, prepare, and manipulate the data through data pre-processing steps. And after that, we'll be training the data. We'll be training the model on the given clean data that we have processed. After that, we'll test the data and then we'll improve our classification algorithm on all the data. So the data set is taken from academics.com. It is a very credible source, credible forum. This forum basically collects the academic details of users to evaluate their profile against past experience. So we write a web crawler to scrap the data, and the unnecessary data is removed from the data set. So this is the screenshot for data set. We have the username, we have the major, we have the research experience, the industry experience, the specialization in which the person did. So here we can see a lot of uh, a lot of dirty data is present, which we'll clean off in the data pre-processing step. We also create a correlation matrix. So the correlation matrix is basically a covariance matrix. It defines the correlation between the different parameters that we have in the data set. It summarizes the strength and direction of the linear association between two quantitative variables. We have also given a screenshot of the general statistics. So like we have the GMAT score, the CGPA scale, the topper CGPA in the dataset. Here we then we use the data pre-processing step. Here we see which columns are relevant for us and which are not. So the term and year is an irrelevant data for our model. So we remove that. Similarly, we also remove the username, TOEFL, essay, and user profile link, because these do not help our model in any case. So we do that. After that, we do encoding. So encoding is a step in which we basically if we have specialization like computer science and CSE, so both of them will be in the same category. So we put those data, we encode them manually. Okay. Next, we do feature scaling. Feature scaling is basically uh, putting the numbers between 0 and 1. It is basically scaling the different entries that we have. So let's just say, for example, the CGPA of someone is given, some student is in a university is from ranges from 0 to 5, and from in another university ranges from 0 to 10. So we'll scale both of them in between 0 to 1. So we use this normalization technique. which is given as x change is equal to x minus x min by x max minus x min. After that, we do oversampling. Oversampling is used when the amount of data collected is insufficient in some form. We use a technique known as synthetic minority oversampling technique, which creates synthetic samples by randomly sampling the characteristics from occurrences in the minority class. So initially we had the university name distribution like this, about 3,000 for the different universities. After oversampling, we increase the number of frequency of trained data set. After that, we use categorical intercoding, which is the binarization of encoding variable. It helps to prevent implicit weightage to particular class. For example, if we have a data set like country, which is given as France, Spain, and Germany. So we'll encode them like 0, 1, 2. So one way is uh, to give them number for the countries such as 0, 1, 2, but that actually is bad for our model. So we'll encode them like 0, 0, 1, 0, 1, 0, like that. After that, we'll split the data into training and testing set. We use a method called cross-validation, which is the resampling procedure used to evaluate machine learning models on a limited data sample. It has the following steps. Firstly, we shuffle the data set randomly. Then we split the data set into k groups. After, for each unique group, we take the group as a holdout or test data set. Take the remaining group as training data set. We fit the model in the training set and evaluate in test set. We retain the evaluation score and discard the model. So we do this for n number of times, and after that we get a cross-val score. So cross-val score may be underfitting, overfitting, or just right. So underfitting means that the model is performing very poorly. Overfitting means that the model is performing very good. So we don't need all that, because if the model is performing very good, then that means that our prediction might be wrong if we give that. So we need to find a just the right amount of loss. Now the models we have trained are random forest, support vector machine, and k-nearest neighbor. So we train the models using the dataset. After all the cleaning procedure of the dataset, we train the models, and then we test the models on the using cross-val score and model accuracy. So for support vector machine, we get the result as follows. The cross-val score of the model comes out to be 66%, and the model accuracy comes out to be 66%, 66.08. So, and the confusion matrix is given as such. Similarly, for the k-nearest neighbor, we get the cross-val score as 65%, and the model accuracy comes out to be 77%. For random forest, the cross-val score comes out to be 72%, and the model accuracy is quite high, which means the model is overfitting. So it comes out to be 99%. In conclusion, the three classification algorithm that we have trained using the data set, which is random forest, k-nearest neighbor, and SVM, they have been used for the building of the university recommendation system. After this, the future goal is to uh, help this is also to implement a different feature, which is to evaluate the research paper of the students. Like if the student has written research paper has been published in a journal, or which has been published in a conference, so the feature will rate the research paper according to that. That will be. Thank you.
And our topic of presentation is Alzheimer's disease stages classification using MRI and deep learning. So Alzheimer is a neurodegenerative disorder that affects millions of people worldwide. And an easy diagnosis is crucial for the effective treatment. Um MRI, which is the most powerful tool that is used to detect the Alzheimer's. But the main problem in it is that it's time consuming and you need to refer to an expert for the analysis. So what our plan here is to use deep learning algorithms for classifying the Alzheimer's into its stages so that we could detect them early and a more effective treatment could be planned. For dataset and pre-processing, this is the random images of our dataset. We used MRI datasets and the classes were four named non-demented, mild demented, very mild demented, and demented. And for pre-processing techniques, we used one-hot encoders and image data generator for rotating and stuff. One of first model that we used was Inception V3. It's basically a deep CNN architecture that was introduced by Google in 2015. It's designed for large-scale image classification tasks and has achieved already a high accuracy on the benchmark data sets. So the main difference in Inception Net V3 architecture is that a module it does multiple processing of convolution layer with different filter sizes, and also the filter size differs. So at the end, the model can be trained with different resolution of images so that the accuracy would be increased. This is basically the plot of the history of the model training, and from here you can notice that the accuracy that this model gave was just 62.39%.
Yeah, hello. So now we can talk about the efficient net B0. So efficient net B0 is a deep learning model that has gained popularity in computer vision tasks due to its excellent performance. EfficientNet is the baseline network developed by AutoML. In our study, we evaluated its performance for Alzheimer's disease classification. One of the key features of the B0 is the use of NB-conv or mobile inverted residual bottleneck convolution. Its architecture is the visualized table as you can see in the slide, which which contains the column for stage, operator, resolution, channel, and layer. Each row represents the building block, with the final block consisting of a combination of convolution and pooling layers, followed by fully connected layers for classification. In the next slide, we can see. So yeah, in the next slide, we can observe our result, which was is the graphical form of our result, which shows that the efficient net model achieved the highest validation accuracy of 97.03% in our dataset. Yeah. So our next is CNN, Convolution Neural Network. It was first introduced in 1980s by Yan Li Shun. The CNN consists of two main components: feature extraction and classification. The feature extraction includes input layer, convolution layer, and pooling layer. These layers extract the feature from the images. Convolution layer applies a set of filters to the input images and produce a feature map. Pooling layer reduces the spatial size of the feature map by selecting the most important features, and the classification includes fully connected layer and output layer. Fully connected layer takes the extracted features and maps them into a set of classes, and our output layer produces the final class prediction using softmax activation. So CNN has shown a great success in image classification tasks due to its ability to extract the relevant feature from the images. Next, we can see that the results shown in the custom CNN model achieved highest accuracy of 98.75. This finding suggests that our custom CNN model is highly proficient in identifying and extracting complex pattern and feature from medical images and enabling accurate classification of Alzheimer's diseases. So yeah, so we evaluated the models based on their accuracy and loss on the test sets. The result indicates that the CNN model outperformed the other models over the highest accuracy of 98.75 and the lowest loss of 5.28%. And the efficient net model has the second highest accuracy of 97.03% and a loss of 7.68%, while the Inception V3 model has the lowest accuracy of 62.39% and highest loss of 128.09. This finding highlights the importance of selecting the appropriate deep learning model for specific tasks, as different model may have varying levels of performance, and the CNN model performed the best in our study, indicating that it is the promising model for the accurate and enabling diagnosis in Alzheimer's diseases. In conclusion, our study demonstrated the effectiveness of transfer learning using deep learning model for the classification of Alzheimer's diseases stages using MRI images, the use of computer-aided diagnosis tools that can be assist medical professionals in accurate and timely diagnosis of Alzheimer's disease has important implication in reducing the burden of healthcare system over patients' outcome, improve patients' outcome. Thank you.
Beijing Hagos from National Taiwan University of Science and Technology under Department of Graduate of Applied Science and Technology. And my research conference title is Electrochemical Method of Biosynthesis using butyric solvents, and the optimization were conducted using PPT, box spin design. And I am a presenter, Beijing Hagos, and and Professor Wang from National Taiwan University of Science and Technology. There are two different universities. Here is the outline, introduction, method, result, and conclusion, acknowledgement. So, biodiesel is an alkyl ester derived from triglyceride and alcohols in the presence or absence of catalysts. And this biodiesel is used directly or blended with petrol diesel in transportation process. And these biodiesels are very important because of its environmental and renewable benefits. So in this study, we use DS as supporting electrolytes, and they are prepared from hydrogen bonding donor and hydrogen bonding acceptors. So they are non-toxicity, and they have biodegradability, and they exhibit electrochemical properties. This electrochemical method is unique. It involves passing direct current through the reaction process, and during the reaction, it generates OH from the electrolysis of water, and this can be applied as catalyst instead of adding X catalysis. So it has low energy consumption, and it is maintained at room temperature. So in previous researchers, electrolysis have some challenges. One is the reaction process is slow. So we designed in this with no co-solvent, and DS can be reused, and it is environmentally reduced. So here is the electrolysis process method. We synthesize DSs, and then we add the process parameters into the electrolysis process of transesterification, separation, and then biodiesel is produced, and then directly applied to transportation. And the DS is also reused 4 times. Here are the various types of DSs screened based on the biodiesel yield, and we found choline chloride ethylene glycol with molar ratio of 1:2 is the highest biodiesel yield, and because of its highest electrical conductivity. And in this table, choline chloride, PTSA is also have higher electrical conductivity, but the biodiesel is very low. This is because PTSA is acid, and acids are not suitable for electrolysis process because of consuming the OH minus catalyst. And so base catalysts are suitable for electrolysis. So this table is conducted under this reaction conditions. Here is a table we use it for response surface optimization, the coded one and the actual ones, 3 variables, BPT. And based on this, 27 experimental optimizations were conducted, and here are the results. And the results are repeated 3 times, and we take the average value. Here is a developed second quadratic model equation using the 27 experimental results. And when we see the based on this model, the actual yield and the predicted yield, they are on the same lines. This is a relationship graph, and they are in the same line. That means they are excellent correlating each other, and the model is best fit. And here is the 3D plot of combined interaction effects of the process variables. We have 4 types of process variables, and here are the 3 plots of each. So before the optimum condition is obtained, the interaction of each is increased, and after the optimum conditions in all of them, in case of DS, there is a slight decrease after excess amount of DS is added. This is due to the limited mass transfer process during electrolysis process. In case of electrolysis voltage, we found after the optimum condition, the biological yield is stable and remains constant. Here in methanol to oil molar ratio, when we increase maximum excess after the optimum condition, the biological yield decreased because of the diluting the reactants. So those are the combined interaction effects. In case of water is very important. It facilitates the reaction process. But after optimization, it has its own negative effect to the reaction. It decreases the yield due to the formations of free fat acids in the reaction. Here is the reusability of DS2 in the electrolysis process. So DS2 was reused 4 times at optimum conditions, and the biological yield was found greater than 80%. So this shows that this DS is a promising catalyst for electrolysis. Here are the fat acids synthesized in from soybean oil, fresh soybean oil. So we found 5 free fat acids, and their composition percentage were displayed. And here, the highest percentage composition was found in the unsaturated fat acids. The existence of this large amount of unsaturated fat acids can reduce the melting point of the biological yield, so they will be effective for as diesel. I can summarize the conclusion. Among the various DSs, we screened different types of DSs at different molar ratios. From this, we found the choline chloride with ethyl glycol with 1:1 molar ratio exhibits the highest efficiency. And we screened this for further experimental optimizations. And as the optimum reaction conditions, the highest biodiesel was found 94.71% yield. And the DS was reused 3 times and demonstrated with greater than 80% yield. So we can suggest that this DS assisted electrolysis is a promising, cost-effective, environmental friendly, and efficient for biodiesel production. Therefore, the results were found helpful for industrial applications. This research was conducted or financially supported for Ministry of Science and Technology of Taiwan.
Thank you for your wonderful.